Calculate and interpret yield spread measures for floating rate instruments. And again, I'm drawing your attention to the word calculate here. Okay, floating rate instruments. This could refer to floating rate bonds or bank loans. The reference rate is usually some short-term money market rate, such as SOFR, the Secured Overnight Funding Rate. You may still come across LIBOR in some other readings or in some other material produced by maybe one of the investment banks, a primer on yield measures, for example. You may see the reference for LIBOR. Whenever you see that, just substitute it with SOFR. You don't have to say, well, we don't use LIBOR. What do we do now? LIBOR is just a term that was used for a particular reference rate. It wasn't a market reference rate, though. That's why we've dropped off LIBOR. We're now using a market reference rate. But again, whenever you see LIBOR, just cross it out and put market reference rate in there instead, and no loss of understanding. So the yield on a floating rate instrument is typically stated as some market reference rate plus some spread. And the market reference rate may be a 1-month rate, a 3-month, or a 6-month market reference rate. More commonly than not, it is the 3-month. And then you have some spread, which is the quoted margin. You'll see that on the next screen. The rate is determined at the beginning of the period and paid at the end. Well, that's not surprising, right? When you go to the bank and you deposit $100 and you say, well, what interest rate am I going to get? You're quoted the interest rate today, and then you come back at the end of whatever deposit period and you get your $100 plus your interest. Same thing for a floating rate bond. At the beginning of the period of time, we can observe what a 90-day market reference rate is. Let's say it's 3%, and that is the interest rate over that period of time. Well, at least that's the market reference rate, and then you'll have some spread on that. So the market reference rate is determined at the beginning of the period, paid at the end. This is the big difference between floating rate bonds and fixed rate bonds. It comes in the price, the amount of interest rate risk that you take on in terms of the price. When you have a fixed coupon and interest rates change, the price has to change because you have to get a certain yield. If required yields increase, well, the coupon is fixed. I can't get more out of the coupon, so I got to buy the bond at a cheaper price to make up for it. However, with a floating rate bond, as the market rate changes, the coupon changes. So the price tends to stay more stable. Well, I shouldn't say more stable. The price tends to stay stable as long as the spread remains stable. All right, let's look at some day count conventions for floating rate bonds. Slightly different than what we saw in fixed rate. In fixed rate, we saw actual. I'll write it here for you. We saw actual, which will compare with this one, and we saw 360. Well, with floating rate bonds, we have actual over 365, which is really actual over actual, so really nothing changes there. And we have actual over 360 versus what we saw before, 30 over 360. So notice that we have actual for floating rate bond instead of 30. So actual for fixed compares with actual over 365 for floating, but 30 over 360 does not compare with actual over 360, the actual being for floating. Just be aware of that. Let's introduce some terminology. We're going to look at 3 words here. We're going to look at a quoted margin, a required margin, and down at the bottom we're going to look at a discount margin. And spoiler alert, the required margin and the discount margin really are the same thing. So the yield spread over the reference rate, remember the reference rate is some money market rate. Well, a yield spread over that is called a quoted margin. So when we move away from government securities, which are risk-free, into risky securities, suddenly we're going to have a quoted margin. It is credit related. So the riskier the bond, the floating rate note that we're buying, the higher the quoted margin would be. Now, in that margin are other things. There's some basis points in there for liquidity risk. There are some basis points in there for perhaps the tax treatment of the bond, but they're small. So we tend to just ignore those and attribute the quoted margin entirely to credit-related events or the credit worthiness of the particular issuer. It's theoretically incorrect, but practically it makes no difference. So in a practical application, it's okay just to say, well, the quoted margin has to do with just the credit issue of the particular bond. May even be negative. Sub-LIBOR. How can that be? Well, LIBOR, recall, is an interbank rate. That's the rate at which banks will lend to each other, and banks are typically rated AA. So if you have an issuer that has a AAA rating, well, then it'll be able to issue a floating rate note at LIBOR minus some basis points. The required margin. This is the spread required by investors to reflect changes in credit quality. So when a floating rate issue is first floated or first issued to the market, it'll have some spread over a reference rate, some quoted margin reflecting its credit quality at that time. That credit quality may improve or it may deteriorate over time, while the required margin would catch that. It would say, well, the quoted margin is either too big or too small, so here's what we need now. Changes usually come from changes in the issuer's credit risk. So changes in the quoted margin to the required margin pretty much come from the issuer's credit risk. Again, it's not theoretically correct to say it's just credit risk, but for practical purpose, we're just going to stop there. Therefore, an FRN, a floating rate note with a quoted margin of 50 basis points with no changes in credit risk, the required margin will still remain at 50 basis points. So let's look at the pricing of an FRN assuming no changes in credit quality between payment dates. So on a payment date, if the required margin equals the quoted margin, the floating rate note will have a price of 100. On the next payment date, if the same thing holds, no changes in credit rating, the price of the floating rate note again will be 100. But in between payment dates, it can trade at a premium or a discount. So the present value could be a premium or a discount between payment dates for changes in the reference rate, because on this date, LIBOR may be a certain rate, but it fluctuates over time. So if we were going to price the bond in between coupon dates, we have to reflect the fact that, well, LIBOR is not going to be the same as it was on the payment date, but it would only be the next payment that would fluctuate with changes in the market rate, because on the next date, it would then be reset to 100 again, because, well, all coupons would be priced at their own market rate. But the present value is pulled to par as the payment date nears, and that's why we have this. Unless there was changes in the credit quality of the issuer, then we end up down here. Here's a couple of if statements. So some terminology, well, not terminology, notation. You're going to need this notation on the next screen. QM will stand for quoted margin. DM will stand for discount margin. So we'll drop the whole idea of required margin. And we'll just call it the discount margin. The discount margin is the margin required by the market. How's that? So if QM equals DM, then present value will equal 100 on a reset date. If the quoted margin is greater than the discount margin, that means the market doesn't want so much, present value will be greater than 100. It'll be trading at a premium. Things got better. But if the quoted margin is less than the discount margin, in other words, the market is saying, hey, we need a little bit more margin now. You guys are not as great as you used to be. We need to be paid more. The present value of the floating rate note on a reset date will be less than 100. So right at the top of the screen, there's our formula for pricing out a floating rate note. And notice the word here, calculate. So you're probably thinking, oh, come on, man, look at that formula. How am I ever going to remember that? It is super, super easy to remember. It's actually really just this. We're going to break it down. I'm going to show you. It's just payment over 1 plus r over here. And this is 1 plus r squared, 1 plus r, all the way to 1 plus r to the n. And, of course, there's our future value. So let me prove to you that that's payment. Remember, the floating rate note has a coupon that is the index, whatever the benchmark rate is, plus some quoted margin, plus some spread. Well, there it is right there. There's the index. Index meaning, well, it's LIBOR or whatever. Rather than writing reference rate, we just write index. Index plus a quoted margin. So that's really just the interest rate. So it might be, let's say LIBOR was 2%. That might be 0.02, and the quoted margin was 100 basis points. That might be 0.01. So there's 3%, 0.03 times the future value. Well, that just comes up with a coupon payment, right? So if this were 100, 0.03 times 100, we have 3. and divided by m. M is the periodicity. So if it's 4 times a year, 3 divided by 4, there's 150. That's just your payment. All you're doing is just calculating what the payment is going to be when you get the payment. What do we have on the bottom? We have index plus DM. DM is the discount margin. So if the discount margin, let's say, were 200 basis points, your index is 0.02 plus 0.02 divided by your periodicity, which would be 2, 1 plus R, right? 1 plus, this would be R. And then you go on to the next payment, and the next payment, and we're missing an M in there. Let me just write that in quickly, and that's it. So we can just see that it's really just the present value of the series of cash flows, except we just have to do a little bit of work to figure it, because it's not a fixed rate, it's a floating rate. We just got to do a little bit of work on each one to figure out, well, what is the coupon payment going to be, and what is the discount margin going to be? So let's have a look at how we would price one of these things out here. Let's take a 2-year floating rate note. It pays 6-month LIBOR plus 50 basis points, and let's say 6-month LIBOR is 1.25%. So it pays 6-month LIBOR plus 50 basis points. Right away, I know it's paying 6-month LIBOR. This is a semi-annual bond because it's paying 6-month LIBOR. The required spread is 40 basis points. Look at our quoted margin is 50 basis points. Our discount margin is 40 basis points. So our index, if we're looking at all of these terms up here, our index is 1.25%, 0.0125. Our quoted margin, 50 basis points, 0.005. Our required, or our discount margin, is 0.004. So let's price this thing out. What is our N? 4. It's a 2-year, pay 6-month LIBOR, so I know it's semi-annual, it's 4. What is my payment going to be? Well, my payment is just my numerator up here. Look what I've done. There's my index plus my quoted margin times the future value divided by the periodicity. So I know that my index, LIBOR, is 1.25. I know that my quoted margin over here is 50 basis points, 0.005. Add these two together, multiply by 100 to get the payment, divided by 2 because it's semi-annual, my periodicity. There's my payment, 0.875. What is my discount rate? Well, my discount rate is just this term in here. Just this term. We don't add the 1. It's just that term. So it's the index plus the discount margin over the periodicity. Well, it's 1.25 plus 0.004. Notice up here we use the 5. That's the quoted margin. Here is the discount margin over the periodicity. It's semi-annual. Divided by 2, we get 0.825. So I got my N. I got my payment. I got my discount factor. My future value is going to be 100. Compute PV, 100.196. Does that make sense? It's not priced at 100 on a rate reset date. Does that make sense? Well, look at our quoted margin, 50 basis points. Look at our discount margin, 40 basis points. Since the quoted margin is greater than that, and then the discount margin, we're going to have a premium bond. Therefore, present value will be greater than 100. So you don't really have to do a lot of work with this formula at all. It just gives you an idea of how to conceptualize what the present value is going to be. It's still the present value of a series of cash flows. Here's the thing, you cannot use this formula at all to get to the present value. Does anybody know why? Think about a timeline. Here's a payment date, here's a payment date, here's a payment date, here's a payment date. Well, the payment you're going to get here is based on LIBOR that we saw here. The payment that you're going to get here is based on LIBOR that we saw here. Well, you can't see LIBOR there. All of these other indexes here, this can't see, this can't see, because it's in the future. Remember, it's floating, it's a market rate, so you can't really see it, it's in the future. However, if each payment is discounted back by its own rate, you will have a par bond. So you really only need to know the difference between the quoted margin and the discount margin. If the quoted margin and the discount margin are the same, let me give you a really, really fast shortcut to get to the price of a floating rate note on a rate reset date. If the quoted margin and the discount margin is the same, present value equals 100. I'm done. That's it. That's a wrap. 100. Nothing more. I don't need to do anything more. The only time we have to do something more is when they're different, and we can just use the time value of money keys as we've done here. N equals 4, figure out our payment, which is just the numerator here, figure out our discount rate, which is just this term in the denominator. Our future value is still going to be 100, compute the present value. That's it. All right, so we've already been through a good example of how to find the present value or price out a floating rate note. Let's say that we have prices of floating rate notes and we want to figure out, well, what was the discount margin? Because we'll know everything else. The quoted margin is part of the bond indenture, part of the bond deed. We'll have that stated right up front. So let's go through a couple of examples of what we're talking about here and how we would do it. Let's do our setup. 5-year floating rate note pays 3-month LIBOR. The quoted margin is 75 basis points. It's currently priced at 95.50. What's the market got the discount margin at, given this setup? And let's assume 3-month LIBOR is 1.1%. So I know this is a quarterly bond because it's paying 3-month LIBOR. So I want to find my discount margin. The best way to find my discount margin is to say, well, given everything I know about this bond and this price, what is the yield to maturity on this bond? Once I know the yield to maturity, I can just subtract what the index is, and whatever's left over must be my discount margin. So let's go. Time value of money keys. N, well, it's a 5-year floating rate note paying 3-month LIBOR, so it's quarterly. 5 times 4 is 20. My future value is always 100. My present value is 95.50 or negative 95.50. My payment, this is the only work I really have to do. It's index plus the quoted margin over 4. Why am I dividing it by 4? Because it's 3-month LIBOR. It's quarterly, right? Multiplied by the future values. So my index is 1.1 plus 75 basis points. So my index plus the quoted margin is 1.85 divided by 4 times 100 is 0.4625. So I got my N, I got my FV, my PV, and I've got my payment. Compute my yield to maturity. It is 0.7045, but that's quarterly. So I annualize it, right? Multiplied by 4 and subtract 1.1%, which is 3-month LIBOR. That'll give me my discount margin. My discount margin here is 171.8 basis points. So if I saw a floating rate note with these characteristics, 5-year floating rate note paying 3-month LIBOR with a quoted margin of 75, selling at 95.50, I know that the market is saying that 75 basis points, that is not enough. We need priced out at 171.8 basis points to get to this 95.50. So the market has got the discount margin at 171.8. Now we can look at that and say, is the market right? Is that too much or is it too little? We might look at the 171 and say, well, you know, I know that the last earnings report was a little negative, but it doesn't call for a credit downgrade to that extent. I think that's overdone. I would be a buyer of this particular bond because I would think that that discount margin is going to shrink over time. And when rates go down, what happens to prices of bonds? They go up. Let's look at our next one. What's our setup? We got a 4-year FRN paying 3-month Euribor. It's not LIBOR, Euribor. It's still an interbank rate. It's just the same thing. It's an index. It's just a different index. That's all. So we shouldn't be thrown by that. It's just like, okay, well, that's our reference rate. It's 3-month Euribor. So I know it's a quarterly bond. It's set at 2%. Plus 125 basis points, and we observe the price at 98. What is the discount margin? Now, right away, I'm going to look at this. I'm going to say, well, my quoted margin is 125. It's selling at a discount, which means the discount margin must be greater than 125 basis points. So if I got a multiple choice question on an exam, right away I know I'm looking for a discount margin greater than 125 basis points. At this point, I might look at my A, B, C choices, and if A and B are both lower than 125 basis points, well, I don't even have to solve anything. Right away I know that A and B must be wrong because the discount margin must be greater than the quoted margin. So I would just take that one. I wouldn't even have to calculate. Let's just do it anyways. Our goal is to get enough information so that we can use the time value of money keys to get our yield to maturity. Because once we have our yield to maturity, we can annualize it. Once we annualize it, we can subtract the index portion of it. The difference must be the discount margin, right? What's my N? 4-year floating rate note, quarterly, 4 times 4 is 16. There, that's done. My future value, that's a gift. It's always 100. My PV, well, I'm told what it is. It's negative 98. The only work I really got to do is to figure out my payment. Well, here's my payment here. Remember, it's the index plus the quoted margin divided by the periodicity, and then we multiply it by the future values of the bond to get the payment that we're making. So 2% is our index, 125 basis points. So we get 3.25%. divided by 4 to get quarterly, multiply it by 100, we get 0.8125. There's our payment, 0.8125. You can also just say, well, it's 0.02 plus 0.0125 or 0.0325 multiplied by the 100 and then divided by 4, but it's the same thing. Take this, divide it by 4 and multiply it by 100, or take this, multiply by 100 and divide by 4. You get to the same thing. Whichever way you see it in your mind that makes sense to you, go ahead. So there is our yield to maturity. Let's annualize it by multiplying it by 4. Then we're going to subtract the index, which is 2%. That'll give us our discount margin, 0.017912. We usually express it in basis points, so it'll be 179.12 basis points. Does that make sense? Well, the quoted margin is 125. This thing is selling at a discount, which means the discount margin must be greater than the quoted margin. It is. At least I'm in the right direction. I don't know if I'm exactly right, maybe, but I know that I'm in the right direction. 179 is greater than 125. My answer is consistent with a discount price. All right, one last thing to look at here. Recall that we had seen this formula earlier. This is for calculating the present value of a floating rate bond. Notice that we have in the numerator here MRR, and we have the same MRR in the denominator, and we make no distinction among the MRRs. They're all the same. So it assumes that MRR is the same for all cash flows. That's not really reality here. We don't discount all of the cash flows at whatever the MRR is. At any point in time, we're discounting cash flows by the appropriate spot rate. Remember, in fixed rate securities, we have our payment, and we discount it by 1 plus whatever the first spot rate is, and our second payment we'll discount by 1 plus Z2, whatever that spot rate is, squared. Well, we want to do the same with a floating rate bond, discount each cash flow by its spot rate. To do that, we are going to need some estimate of what the payment would be. For that, we can use a forward curve and use forward rates. So instead of a discount margin, if we're doing it that way, we would use something called a zero discount margin, which is the constant discount margin added to each spot rate. Remember what the Z-spread was? The Z-spread was a constant spread added to each spot rate. So when we have a floating rate, now we have something called the zero discount margin, which is the constant discount margin added to each spot rate. So the formula changes and looks like this. Remember, the first coupon payment, we're already going to know what the market reference rate is on day one. But then we start using forward rates on day one if we're calculating the present value. For the next 3-month period, we'll look at what the forward rate is. For the next 3-month period, on and on, so F33, F63, F93, what is this? This is a 3-month rate in 3 months, a 3-month rate in 6 months, a 3-month rate in 9 months, a 3-month rate in 12 months, on and on. We use forward rates in our numerators, and we're going to use spot rates, not market reference rates, in our denominator. And when we do that, we need a discount margin that we calculate some constant amount added to each spot rate. You don't have to deal with the zero discount margin a lot at level 1. You just have to understand that the more appropriate way to price out a floating rate note is by using forward rates in the numerator, spot rates in the denominator. When we do that, our discount margin turns into a zero discount margin. You will see the zero discount margin again at level 3, and hopefully it won't cause you the same grief it causes many people at level 3, because now you get it. Calculate and interpret yield measures for money market instruments. Another calculate here. So that means we've done yield measures and spreads for fixed rate bonds, for floating rate bonds, and now we're looking at money market instruments. All right, we've looked at yield measures for fixed rate, for floating rate. Now we're going to look at yield measures for money market instruments. And at the beginning of LOSF, I took a little bit of time to distinguish between annualized rates versus compounded rates. For money market instruments, any yield measure we calculate will be annualized but not compounded. That's important. annualized but not compounded. Now, this simple little statement here will save you a lot of grief if you can remember this at level 2, because there'll be parts in fixed income at level 2 where you'll stop and say, why are we not compounding these? Why are we just using simple interest? Because money market rates, money market instruments, annualized but not compounded. Instead, rates of return are stated on a simple interest rate basis. That's it. And rates of return can either be discount rates or add-on rates. Securities that are quoted on a discount rate, T-bills, commercial paper, bankers' acceptance, add-on rate, certificates of deposit, repos. An add-on rate's really easy. You go buy a certificate of deposit, you'll pay $1,000, let's say, and sometime in the future you'll get back $1,000 plus interest. There's your add-on rate right there. Whatever your add-on rate is, you can calculate your interest. Nice and simple. For these other securities, you don't buy something for $1,000 and then in the future get $1,000 plus interest. In the future, you get $1,000. You got to figure out, well, what do we give today to get that $1,000 in the future? Remember, money market instruments are quoted on a discount basis. We buy them at a discount, they mature at par. So we might have a discount rate associated with that security. Now, the discount rate is not really that difficult to figure out. I'm going to give you a really easy example where you say, oh, well, duh, of course that's the discount rate. Of course that's what it equals. Let's look at the top here. 1 year. And in a year, you're going to get $1,000. And I tell you that this security is quoted at a discount rate of 2%. How much would you pay today? Now, you'd say, well, 2% of $1,000 is $20, which means I'm going to pay $9.80 today. Yeah, that's it. That's exactly it. That's all it is. Problem is with money market securities is you don't have a year. You might have 91 days. You might have 147 days. You might have 221 days. And your year might be based on a 360-day year. Well, what if I quote you this $1,000 for, let's say, an 84-day T-bill based on a 360-day year quoted at a discount rate of 2%? Suddenly it's like, yeah, how would I do that? So it's fairly straightforward. We can arrive at our present value of any of these securities if we know our discount rate. We know what our future value is going to be. It'll be the face value, the par value of whatever we're buying. And it's 1 minus days over years multiplied by the discount rate. Now, let me just use this example, this 1 year. I'll use this particular formula with this 1 year thing so you can see what's going on inside of here. Our future value was $1,000 multiplied by 1 minus, and it's days over years. So since the number of days that we're holding it is 1 year, it would be 1 times the discount rate. 1 times the discount rate is just the discount rate, so it would be 1 minus 0.02. 1,000 times 0.98 is 980. That's all we're doing. Let's say we held it for half a year, exactly half a year. Well, days over year would be 0.5 times the discount rate, which is 0.5 times 2% is 1%. This would be 1,000 multiplied by 0.99 or 990. So this is just saying, okay, yeah, you know what? For money markets, it's all messed up. Sometimes a security could be a 91-day security, a 100-day security, a 123-day security. We need some consistent way to figure it out. So this is all that. That's all this is doing in there. That's really all that's doing. So let's look at an example and see what we get here. Let's take a 91-day T-bill. It matures at $10 million. It's quoted at a discount rate of 2.25, and it's a 360-day year. See how messy this can get? It's not a 365-day year, 360-day year. Now remember, we're going to use actual over 360 in this case, right? So present value is 10 million. That's what we're getting in the future, multiplied by 1 minus whatever the discount is. Well, we know it's 2.25%, but it's only for 91 out of 360 days. So 91 over 360 multiplied by this. There we go. 9,943,125 is the present value today, quoted at a discount rate of 2.25%. Now, if, just to show you how easy this is, let's say this was not a 91-day T-bill. Let's say it was a 360-day T-bill. It's a 360-day year, quoted at a discount rate of 2.25. Well, this would be 360 over 360, which is 1. It would just be 10 million. Multiplied by 1 minus 2, well, it's not 2. 0.0225. It would just be 97.75% of whatever the 10 million is. We just discount it by 2.25%. That's why it's called the discount rate. Let's say that we want to solve just for the discount rate. So we know how to use this particular formula. If we want to solve just for the discount rate, all we have to do is just multiply through, use algebra, solve, and isolate dr. You'll get this over here. You'll get years over days multiplied by future value minus present value over future value. Let's break this down. Years over days, that's periodicity. So if we have this 91-day T-bill, well, if we flip it around and put year, which is 360, it's a 360-day year over 91. 360 divided by 91, that tells us how many times a year we can invest in a 91-day T-bill. So that's really just the periodicity. Let's look at this term. What is the numerator? Future value is what we're going to get. Present value is what we pay. That must be the interest earned. The difference between the two is the interest earned divided by, there's the oddity, divided by future value. It should be divided by the present value, right? This is the number of times a year that we can make this much money, but it's not, because this is future value. If this were present value, this would make a lot of sense, but it's future value. So we should be aware of it. So I make a note here. Future value, not present value. Therefore, the discount rate will understate the rate of return to the investor and the cost of funds to the borrower. Now, an add-on rate is real easy. Remember, I said an add-on rate is if we're going to buy something for $1,000 and we know the add-on rate, let's say it's 3% is the add-on rate and it's for 1 year. It would be 1,000 multiplied by 1.03, which equals 1,030. That's what we're going to get in the future. It's just added on, not discounted. So present value equals our future value divided by our discount rate. And this is all this is. This is basically what we saw on the other page with the DR, except now we're using an add-on rate. So our future value, if we take 1,030, let's just make sure that we can do this. 1 over days over year. I said if it were 1 year, what would this be? This would be 1 multiplied by AOR. I said 3. So 1030 divided by 1.03 would get us back to our $1,000 present value. All we have to do now is just isolate AOR. We're going to see why are we isolating DR and AOR. Is because once we isolate those, it makes it easy to be able to convert from discount rates to add-on rates. So if we isolate AOR, what do we get? Years over days, we get periodicity. Same thing we had when we isolated DR. We get FV minus PV in the numerator. Same thing. The only thing that changes is the denominator, PV. So DR is the same thing, except this is FV. AOR, same thing, except this is PV. Again, periodicity, and this here is interest earned over price paid. Let's look at some examples, and we'll end with a really detailed look at how we can compare securities that are quoted on a discount rate versus add-on rate. 180-day banker's acceptance, add-on rate of 4.38%, 365-day year, and it's a $10 million issue. Well, 10 million is what it is today, right? We got to figure out what our future value is. So our future value is just what it is today multiplied by the interest over that period of time. So it's 10 million multiplied by 1 plus, and all of this is just R. We know R is 4.38%, but it's only for 180 of the 365 days. So it's 180 over 365 times the rate, add to 1, multiplied by the 10 million. We get 10,216,000 is what the future value would be. And that's how add-on rates work. It's really simple. You just say, well, how much is it today? I know what the rate is. Over what period of time is it for? And that's what I'll get in the future. Note, if future value is quoted this way, or if we solve for future value as our present value multiplied by 1 plus r to the n, that's compound interest. In this case, what we did was we solved for our future value by taking present value what period of time is it for, and that's what I'll get in the future. Note, if future value is quoted this way, or if we solve for future value as our present value multiplied by 1 plus r to the n, that's compound interest. In this case, what we did was we solved for our future value by taking present value 1 plus days over years times r. That is simple interest. This is going to be a big deal at level 2. That's why I'm taking the time now, because at level 2 I tell you to review this particular reading. And when you're reviewing this particular reading, you'll start saying, okay, that's why we're doing it. I get it. So if you can remember this going forward, very good. So this simple interest is a money market yield. Okay, let's get back to our example here now that I've pointed out those little two things. Let's say that after we buy this, 45 days later we want to sell when the add-on rate is 4.17%. What would we sell it for? Well, we need a present value. We got to solve for present value, which is what this thing is up here, right? That's what we were working with that for. Well, we know what the future value is going to be of this 180-day banker's acceptance. We know what it is now. It's going to be $10,216,000 because it was calculated with this add-on rate of 4.38%. That's not going to change. No matter what happens as time passes, we're going to get $10,216,000. That's a done deal. So if we want to sell it after 45 days, well, what's it going to be worth? Well, we have to discount our future value by the new interest rate for that period of time. So the new interest rate is 4.17%, but it's only going to be for 135 of the 365 days. How do I know that? Well, it's a 180-day banker's acceptance. 45 days has passed, so there's only 135 days left. So if we think about it this way, there's 180 days. So this is the future value over here. This is the present value over here. If we want to price it out 45 days in, we got to bring that future value back 135 days because that's 45 days, right? So 135 of the 365 times whatever the rate is, we get 10,060,829. This implies an add-on rate of 4.934%. Notice what I did here, 365 over 45. We held it for 45 days, right? So there are 365 days in the year. We held it for 45 days. That's our periodicity. 10.060829. I just put 10 point. I'm going to subtract 10 over 10 rather than writing out the full 10 million. There's the interest earned over what we paid, 4.934. So it implies that we earned an add-on rate of 4.934, which is higher than the 4.38. Does that make sense? It does. We bought this when the add-on rate was 4.38%, but we sold it when the add-on rate was 4.17%. When interest rates go down, what happens to the price of fixed income securities? They go up. So over these 45 days, we earned some accrued interest, plus we also earned a capital gain because the add-on rate dropped, which means since this is paying a higher rate, this is paying 4.38, the market only wants 4.17, it's willing to pay a little bit more. So we can calculate our effective add-on rate given that we sold it for this price. All right, let's bring it all together now. What complicates the process of comparing money market securities based on their on the yields that they provide, so that we can choose the best one, is some securities are quoted on a discount rate, some are quoted on an add-on rate. Some are quoted on a 360-day year, some are quoted on a 365-day year. So we could have a discount rate security with 365-day year, or a discount rate security with 360-day year, or an add-on rate security with either one of these two dates. How do we compare them all? How do we line up 4 or 5 different money market securities, all with different discount rates and add-on rates quoted, and say, well, which one here is offering the highest return? We can't just look at the rates. We have to find some way to compare them. So what we want to do is we want to convert all money market securities to add-on rates with 365 days. It makes it easy to compare if we can get them all there. That's our goal. So let's walk through a little example here. And when we just look at them right away, let's see if we can figure out which one we like better. Let's take 90-day commercial paper, quoted at a discount rate of 5.76% on a 360-day year. And we're going to compare that with 90-day certificate of deposit. 90 days, 90 days. It's got an add-on rate of 5.9% on a 365-day year. So if we were just looking at the rates, well, they're both 90 days. This is a discount rate of 5.76. This is an add-on rate of 5.9. This is 360 days. This is 365. Which one would you pick? Naively, you might say, well, 5.9 is better than 5.76. I'll pick the 5.9. But this is only over 360 days. This takes 365. Suddenly, you got to say, well, how do I get that? Let's have a look. Let's get a present value for this discount security here, because we know its future value is going to be par. It's going to be 100, and we're just going to price it out as if it were 100. It's going to be 100% of its face value. So the present value is 100 times whatever the discount is, 1 minus, and we're holding it for 90 days out of 360. It's 90 over 360 times the discount rate, 5.76. We get 98.56. Now let's convert it to an add-on rate. To convert it to an add-on rate, all we do is just plug in what we need. 365 over 90. Notice when we calculate the present value, we use 360 days to turn it into an add-on rate. Look at our numerator. We're going to use 365. So it's 365 over 90. That's the periodicity. 100 minus 98.56 over 98.56 gives us 0.05925. So 5.925 versus 5.9. We actually make more buying commercial paper at a discount rate of 5.76 than buying a certificate of deposit with an add-on rate of 5.9. And the rate we arrived at here, this 0.05925, this is a bond equivalent yield for an add-on rate for 365 days. So we do arrive at a bond equivalent yield. Not a big important point, but it's there. Let's do a whole bunch of comparisons here. Let's assume these are all 180-day investments. We have 4 of them, A, B, C, D. A is quoted on a discount rate of 4.33% for 360 days. B has got a discount rate of 4.36 for 365. Then we have 2 add-on rate securities. Here's an add-on rate of 4.35 for 360 days. Here's an add-on rate of 4.45 for 365. We want to convert them all so that we can compare them. Notice we don't have to convert D. D is already an add-on rate at 365 days. That's okay. We can look at that 4.45 and say that's fine. Let's convert the rest. Let's deal with the first one. A discount rate of 4.33 for 360 days. Again, we just calculate the present value. It's a discount rate, so we know the future value is going to be par, 100% of whatever the face value is. 100 times 1 minus the discount. 180 over 360. There's 180 days, 360. Multiplied by 0.0433. We get 97.835, and then we just solve for the add-on rate using 365 in the numerator. 365 over 180. It's 100 minus the present value we arrived at, divided by the present value. We get 4.487. The next one, do the same thing. It's a discount rate, so present value equals 100 multiplied by 1 minus the discount. 180 over 365, because it's 365 days now. Multiplied by 0.0436, we get 97.84 and change. Well, calculate the add-on rate. An add-on rate with 365 days, right? 365 over 180, 100 minus the present value we arrived at, divided by the present value, gives us an add-on rate based on 365 days, 4.456. Finally, we have this last one. It is an add-on rate, but it's only 360 days. We want to get it to 365. We can go right to the formula, and we're going to see where we fall short. So it'll be 365 over 180, and the numerator here is future value minus present value. Well, you know the present value is 100 because it's an add-on rate divided by 100. Well, we don't have any future value, right? That's why we have to first calculate the future value. So if you're asking, well, how do you know that you had to calculate the future value first? Well, all you have to do is just go and calculate the AOR for 365 days, and as you're filling in the numbers, you'll say, I don't have a future value. I got to calculate it. So the future value is just the value today multiplied by 1 plus the interest rate. 180 over 360, because it's 360 days, multiplied by 0.0435. You'll get to 102.175. There's your future value. Plug in your future value here, and we get 4.41%. Which one do we like the best? You have 4.45, 4.41, 4.456, and 4.487. Look at that, 4.487. So when we look at these yields, the discount rate of 4.33 was lower than all of the other ones, but it ended up being the winner because it was based only on 360 days. This was 365, this was add-on at 360, and this was add-on at 365. Unless you can convert them all to the same type of yield measure, you're not going to be able to convert them. So we convert them all to AOR at 365.